Welcome everyone to the online dairy education series that we have been hosting through the University of Vermont over the last week. I know many of you are repeat customers, so it's great to see folks getting on and participating. I feel like we've had a great lineup of speakers and information. I know I've learned a lot over the last few webinars, some fascinating information about cow comfort the other day. And I thought that was really, really interesting. So today we're going to focus our time on forage quality. It's a good time to be thinking about that. Seems how I don't see much green grass, but I'm assuming pretty soon things will start waking up. So forage quality, how to improve it, assess, and just feed more forage. We want to be feeding as much homegrown feed as possible. And hopefully today, Sid Bosworth, who many of you know, it's on the brochure now, a retired extension agronomy specialist, but I believe you're still an agronomist, right, Sid? You didn't hang that hat up totally?
I guess always, once an agronomist, always an agronomist. Right?
Yeah, exactly. Where he served for 30 years with just UVM, I guess. Yeah. Providing research and outreach and education on forage crop management and utilization, forage quality, pasture and grazing management, and pest and weed management. And I know many of you on this call have heard Sid, maybe even Sid was your teacher at one point or an instructor, and I see an advisor for some of you that are on the call. So most of you know Sid. And joining Sid today is Kurt Cotanch, and many of you may also know Kurt from like the old days, right, Kurt, when you were at UVM in the forage testing lab, didn't you?
That was years ago.
Yeah, spent a few years there. And then many of you may know Kurt from the Minor Institute newsletters and his work with the Minor Institute for years. And then he moved on to some other projects on local farms and with cheesemakers. And now he's an independent dairy nutritionist working in Vermont and probably beyond Vermont borders, and really has a strong focus on eating more forage and less grain, which means buying less grain, which is a goal I think we're all really interested in. And so the two of these folks will be presenting as normal. I believe Kurt's going to start. If you have questions, type them in the chat box. And Kurt said it was okay if I just chime in and ask some questions, and the same with Sid. So before I turn it over to Kurt, I just want to thank our sponsors and funders, USDA NIFA, and USDA Risk Management, and also USDA SARE, that are all providing us support to bring education and outreach to the folks that we work with. All right, so Kurt, I don't know if you see the pop-up poll that Sarah came up with this question, so you can see most people, well, not most, yeah, a majority of individuals are using forage tests. So just a little tidbit of information.
Well, we complicate it every other year, just about. So
yeah, right. It's always changing. So all right. So
super.
There you are. I'm gonna shut everything off on my end.
Okay. Well, thank you. Thank you for the opportunity. Thank you for the chance to tag team with Sid here, and thank you for the intro. So let's see. I got to get me out of the way, so I'm not looking at myself. Anyway, so forage quality. That was the topic, and obviously we can go a lot of places with that. But clearly we have some quality forage right here in alfalfa. But that is not the only thing we have. Here's quality forage as well. I was up working at a artisan cheese place, and One of the herds we were working with was a grazing herd, and grasses certainly make up quality forage. And I am a proponent of high quality corn silage as well. If it's good feed, it's good feed. I am not gonna say it's got to be pasture versus a hay crop versus corn. This is forage quality. And how do we assess forage quality? These are the best assessors we have. This was a farm where I was a couple years ago, and we were all dry hay. And this is one pen, no dividers, afternoon, cows coming back from late afternoon milking. And you can see that there's some lush green first cut bale. We were just shaking it out long because we had grain feeders. And the other bale was slightly weathered, so a little discolored, but not moldy in any way. It was still quality feed. But clearly there was a preference based on palatability and forage quality as to which hay cows were choosing over the other. How do we fix that? Because that was going to be a nutritional problem. Management. A lot of nutrition issues can be fixed through management. And what we ended up doing, it took a lot of effort and a lot of people effort to make this happen, but we turned the long dry hay diet into a chopped hay TMR, and obviously homogenized forage quality in that mix, and added whey and so forth. But that was a management issue, fixing a nutrition issue. And ultimately, it really comes down to this. Since we are dealing with ruminants, this is a jaw recording chart from my advisor at UVM years ago. And I think these things are works of art, where we used to have the pneumatic muzzles on cows and record, basically the seismograph recording of their jaw motions. And these are rumination jaw patterns, chew, 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 swallow, regurgitate, chew, chew, chew. And the repetitive nature, the it's the same every time. And it was just, I thought that's a good reminder that we are dealing with ruminants and they require fiber. There's not a starch requirement, but we do have a fiber requirement. This is a slide from Mike Allen from 2005, and it I think clearly represents how Ndf digestibility varies between forage types. And we have alfalfa here on the left, corn silage and orchard grass. And the vertical axis is the in vitro, in the lab, Ndf digestibility value as a percentage of Ndf. And on the x-axis, we have time. And as you can see with this alfalfa example, there's a very good alfalfa where at 24 hours, over 50% of the Ndf is digested. And we have a relatively poor alfalfa where at 24 hours, just over 35% of the alfalfa is digested. Similar statements for the corn. At 24 hours, we can range between 40% digested or up over 60% digested, as well as the grass. Orchard grass can be a nice feed, 24 hours, 50 to 60% digested. The other thing to know is the steepness, the slope of that first portion compared to the slope of the second portion. And what this depicts is the fast degrading fiber, and then there's a slow portion of fiber. And this is critical in understanding forage quality. How big this pool is and how steep it is, and how big that slow pool is and how shallow or slowly digested the slow pool is. And obviously we have that for all forages. And we take this information and we make a little easier schematic in order to put it in computer programs. Originally, years ago, we understood that if this is a forage particle, there's basically two fractions. There's an indigestible fraction and a potentially digestible fraction. And nowadays, we measure the indigestible fiber through what we call Ndf 240. And what this says is undigested NDF corrected for ash, corrected for organic matter at 240 hours of digestion, 10 days. If it's not broken down in 10 days, the only way out of the cow is through passage, K being the rate of passage. The potentially digestible NDF actually can escape the rumen in two ways. It either digests or ends up in the passage pool. Nowadays, the most recent, we understand that based on the previous slide, there's a fast pool of potentially digested NDF and a slower pool, and still the undigestible pool. And that's how our ration programs need to see the forages from the lab. And this I stole from Cumberland Valley. This is a corn silage sample, and there's a myriad of numbers here. But in terms of NDF digestibility, the fiber, this is where I look to first. ANDF, it's just still NDF. It means amylase treated so that we've taken out any starch residues. But what we look at is ANDF on a dry matter basis alone is 38.7% of the sample. When we ash that NDF residue to account for any minerals, either soil or innate minerals, that NDF decreases a little bit. And this is truly the fiber, just the NDF fiber, neutral detergent fiber that's in that sample. The lab will then run digestibilities, and NIR calibrations are quite good actually on estimating 30, 120, and 240 hour digestibilities. So relative to the NDF, it is 55% digestible at 30 hours. After 120 hours, it's 64.7% digested, and so forth. 10 days, if it were to go that long, 69% digested. So when I'm evaluating a feed, I focus on this column, NDFOM, and its digestibility at 30 hours, 120, 240. I don't look at all these other numbers until I get down to the undigested residue on a total dry matter basis. And this tells me whether, boy, of all the dry matter of that corn silage, there's not a whole lot of undigested fiber residue. It's between 12 and 17%, depending on the time point. So that's pretty good corn. I like that corn. There's not a whole lot of slow fiber filling up the rumen with that corn. Obviously, we could go on to starch and the degradability of starch, but we're going to talk just fiber for today. So here we have, I deal with NDS. My other hat that I wear is training people how to use the Cornell dairy ration software. And I deal with the Italian version, the Nutritional Dynamic Systems, NDS. And this is a screenshot from an alfalfa silage, an actual sample, where we took those NDF digestibility values from the 30, 120, and 240 hours. And we simply plug them in, 55, 63, 66. To the right, we have the depiction of the NDF digestion curve. And what this is, the green line is the potentially digestible fiber. The portion where it flattens out and below is the undigested residue that there's no way she can digest. 10-day digestion, it's still there. And based on these digestibilities, the program itself calculates the fast pool, depicted in red, and the slow fiber pool, depicted in blue, and calculates a total rate of digestion, rate of ruminal degradation of that digestible fiber at 8.43%. It's pretty fast. This is a good feed. If we look at a pasture sample, we see that 75% of the NDF is degraded in 30 hours. And after 5 days, 120 hours, 90% of that fiber is gone. And after 10, 92. So that tells me there's only 8% of NDF that is truly indigestible in the rumen. And that's depicted by this curve. We have a huge fast pool. In the first 30 hours here, 75%, in this case, we count downwards. 25% is still remaining, 75% is gone, and so forth. And what I like to do is, if you consider this box to be a rumen, this pasture provides very little gut fill. There's nothing left in the rumen after, very little left in the rumen after 30 hours, and after 60 hours, there's very little left in the rumen. So forage quality comes down to the amount of highly degradable fiber and the amount of slow digesting fiber that fills up that rumen and slows the system down. Not to say that slow fiber is bad, it serves a purpose, but it can be too much. So what influences this UNDF profile or the NDF digestibility profile? Number one is forage maturity. Stage of maturity, when it's lush, it's highly digestible. When it becomes mature and higher lignification, it becomes less digestible. In years previous, lignin was our way of determining indigestibility. Since we've learned that environment plays a huge role beyond just lignin in influencing the crystallinity of cellulose, of plant fiber. We know that there are huge differences between a hot year and a cool year, a wet year and a dry year. The worst combination, hot and wet, decrease digestibility, they increase the undigested residue of NDF. And the easy way to think about it is you move south in the US, where it's hot and wet, digestibility of forages grown down there tends to be much lower than up here in our cool, drier, sometimes drier conditions. Genetics is my third ranking on NDF digestibility. Obviously, there are differences between species, grasses versus legumes, and I'm throwing corn and grass, and obviously cool season versus warm season systems. Spoilage is oftentimes forgotten relative to NDFD. If you do all of these things right and have a wonderful crop, if you don't pack it well, if it gets diseased in the field, if it's frosted before you harvest it, it will just destroy NDF digestibility. So it's got to go into storage and be stored well. This graph I borrowed from Cumberland Valley Labs. Again, it's 2016, tremendous number of samples analyzed, and they separated it out by legumes and grasses, corns, and small grains. And what this is a good depiction of is that as a percent of the samples of legumes, 25% of them were on average 45% NDFD at 30 hours. So in 2016, the average alfalfa came across at 45% NDFD, and you see it made a nice little bell curve. Grass silages, they averaged just almost 55%. But you can see the potential to have highly digestible grass fiber exists. There is a huge amount of grass silages that were over 60% NDFD. Corn silage, the fiber on conventional corn is quite digestible, 55% on average, a narrow bell curve. But if we graduate to the BMR version of corns, we typically increase 30-hour digestibilities by 10 units, from 55 to almost 65%. Small grain silages are becoming one of my favorites, and the reason being is, like grasses, there is a tremendous potential to be in the upper echelons of fiber digestibility. If you get a forage 60% NDFD or better, that can make a lot of microbial protein and provide a lot of energy for the cow. And we all know from, well, we learned that microbial protein, one, can replace the more expensive protein feeds, as well as providing the most optimal profile of amino acids for the cow and protein synthesis. This is one of my favorite show and tells. It's a slight diversion, but it shows you the power of rumen microbes. And what I did here in my minor days is I took a corn silage sample, put them in situ bags, treated them exactly the same as far as soaking them and washing them. This sample went in the rumen for 47 hours. I couldn't wait. I was supposed to wait for 48, but I had to get them out. This sample simply did not go in the rumen, but once this sample came out of the rumen, they were washed together and run through an ANCOM for NDF residues. And you can see the fraying that's occurred. Microbial degradation after 48 hours starts breaking the bonds, and after washing, the fiber is all frayed. This went through the washing machine. It didn't even have its chlorophylls removed or the pigments. Baleage, same story. Look at the amount of cross-linking, the damage to the fibers that the microbes do. Cows didn't chew these samples, just the microbes did this damage. Even straw can be a digestible nutrient if it's chopped finely enough, but you can see the bleaching that's occurred, indicating cells, microbes have opened up the cells and allowed, when I did wash them, the soaps to remove some of the pigments. This is a higher quality grass. These samples were no time in the rumen, 12 hours, 24, 48. And again, it just shows you the time course of microbial destruction of those fibers, creating this tufted wool appearance, as well as total loss of dry matter, compared to this more slowly digested grass sample. It almost looked the same 6 hours later in the rumen. And not only, it took 24 to about 48 hours before that tufting occurred with the plant cell fibers. Okay, so we covered that. The value of forage fiber has great value, and we've understood that, you know, optimally years ago, we thought NDF intake should be at least 1.1 to 1.2% of animal's body weight. And if we're feeding a high cow 64 pounds of TMR at 30% NDF, that cow should be able to consume about 19 pounds of NDF. Previous recommendations were, of that NDF, 75% of it should come from forage, FNDF, forage NDF. So 75% of that 19.2 equates to about 14 pounds of forage NDF should be in that ration for the cow to eat it. Can she eat it? In the case of high digestibility, can she eat more? In the case of low digestibility, what's our limit? Can she even meet 14 pounds? So that was the premise of a study we did at Minor years ago. And these are the two corn silages that were the core of that project. And we have a conventional corn, and here's the digestion profile of that corn. At 30 hours, it had a digestibility of about 50%. In other words, 100% of NDF, it dropped down to about 50% remaining after 30 hours. The BMR at 30 hours, it dropped down to only 35% remaining, or digestibility of 65%. They don't look that different, but you'll see in a minute the huge difference they made in production. The study was designed on low forage, about 50% forage, 50% grain diet, either corn silage or BMR, and then the high forage, somewhere over 60% forage, doing conventional and BMR. This was a high starch conventional corn, very low fiber. So that's why we had to add more into it. The total diet of this trial between the two high forages was nearly identical, 35%. The NDFD values of the total diets are depicted here. On the high forage diet, it was 54. A lot of our digestible NDF was from non-forage fiber in the higher grain diets. Total NDFD, 24-hour NDFDs of the two BMR diets are about 60%. This row right here is something that we theorized. I'm going to come back to it, but I want you to keep in mind this 10-day undigested residue of the whole diet, 10% and 7%. We're going to come back to that. Here were the results. Dry matter intake was the same for the high grain diets and the high BMR diets, 64 pounds. The high conventional corn, they just could not eat it. They only ate 58 pounds of it, and milk production suffered almost a 10 pounds difference, 10-pound drop in milk production, nearly a 10-pound drop in energy corrected milk production. Oddly enough, NDF intake as a percent of body weight was the same for the high corn silage diet and the high grain diets. Only on the high BMR, the more digestible fiber, were they able to consume more total NDF. Cutting to the economics, we look at, obviously, this was the cheapest diet per cow, only because they didn't eat that much. The two grain diets were 722, 744. When they were able to do it with more forage, total cost per cow decreased. Purchase cost per cow, obviously, was lowest on the higher forage diets. When we look at total income over feed costs, it's like, okay, we're going to X this one out because these cows were stuffed. They didn't maximize production. But we see the greatest income over feed is on the high grain BMR diet. Caution. What I'm not telling you is that these cows were approaching acidosis. And since the trial periods were only 4 weeks, just under a month, had they been on this diet much longer, I'm sure we would have seen some severe acidosis. And that's why I'm willing to say, don't look at that number. The two income over feed costs are a typical, 50-50 conventional corn grain diet versus a well over 60% forage from high digestibility forage. And in this case, we had an economic gain of about 30 cents per cow per day. And these are milk component corrected prices. And the grain price for these was the conventional grain cost slightly more than the grain used for the BMR. And the reason for that is because of the BMR, the digestibility of the forage allows us to feed less purchased protein. So I want to go back to this slide. Remember I said this group was acidotic, approaching it. If you're taking notes, total TMR, U240 values of 7% are borderline acidosis. Total TMR, U240 values of 10%, that's gut filling. She can't eat it. The sweet spots were these two diets right here, somewhere between 7 and 10, about 8 to 8.5% of the diet is indigestible fiber, was a safe, productive diet. And when we back calculate to the U240, you see that 14% of the diet was the most productive diet. At 12, they were acidotic. At 16, they couldn't eat it. Okay, so now you're all saying, well, how much more corn do I need in order to do this? And when we calculate the actual pounds of corn consumed in these trials, 32% dry matter pounds of corn in the high forage diets versus 23, 25 in the lower forage diets. If we put them on equal 35% dry matter footings, 92 pounds of corn for high forage, high digestibility, and relative to the conventional diet, that was 50-50, we see that we need about 4 more tons per cow per year if we're going to go high digestibility. That's 30% more. And you're all probably scratching your head and saying, well, if I could have done that before, I would have done it. Consider this. High cows respond best to high digestibility forage. You could get away with this with only 15% above your current forage production. If you're going to make high quality, higher digestibility feed, they're going to eat more of it. You can do it with 15% increase in your yields. And the reason being, there's plenty of data out there that says the gut fill limited cows are the ones that respond best to the improved digestibility. Those are the fresh cows, the high group cows, possibly even the close-up cows. But mid-lactation and tail-end cows do not respond as well to high digestibility forage. And that's why I'm one of the people that jumps up and down and says, you have to segregate this feed. You have to be able to store it separately because you really get the biggest bang for your input if you can feed it just to the early lactation cows. Okay, sorry. Heather's taken me on for a project, and we're talking about forage intake as a percent body weight. So I've done some calculations with this trial, and we see that the body weights were equal across treatments. NDF intake, you can see that the high digestibility, they ate more NDF. At 19 pounds, they were stuffed. If you follow Larry Jones' ideas, where this undigested 30-hour forage number matters, surprisingly, even at high quality forage, at high intake, you may not get the 6 pounds that Larry Jones is looking at and think you're going to run into acidosis. At 7 pounds, they were plug full. So that's why I kind of add on to Larry's thoughts. I like his idea, but NDFD matters when you're talking about pounds of intake. And in this case, we looked at what I call fast NDF. Anything that degrades in 30 hours is fast NDF. And as we see here, between the two grain diets and the high corn silage, similar pounds of fast NDF. Only when we got to fast forage NDF did we see the benefit of similar milk for a lower cost. Fast NDF is a percent body weight, 1%. Caution, we stuffed these cows with too much slow fiber. Their total NDF intake was 1% of body weight, but they didn't do much with it. It needs to be high quality, high, rapidly digestible NDF. So if we're going to shoot for 1% of our body weight as forage NDF intake, we can do it. We can plug them full, but profitability requires that it be digestible. Okay, how do we get there? Current cropping systems, can you harvest a little earlier, get that crop a little more lush, less mature? We know maturity makes the biggest difference. Do you have the weather windows? Do you have the people? Do you have the equipment? Are you waiting on a custom operator, or can you just go when you want to go? Do you have the space to segregate it? And above all, make sure we preserve it well. Inoculants or not, you have to have 50 pounds per cubic foot. Anything less than that, there's too much air remaining in the silage mass. Preservatives or not. Other is your species selection. That graph I showed, comparing legumes versus grasses and the small grains. Maybe there are some advantages to be taken advantage of by changing up some crop varieties if you have that option. Possibly planting a warm season grass, given the drought year last year, would have been opportune to have a heat loving grass crop out there. And also possibly considering this double cropping idea of shortening up your corn maturities in order to make sure you get that fall planting in for spring harvest, if you have the soils to do that. And this is an old slide from Larry Chase, and he's recently updated it at last year's Cornell meeting. And it still holds. The more forage, you can improve components, you can get the same, if not more, milk. The income over feed cost will be better. It's not necessarily a slam dunk, but it will be better. And the fact that you have less acidosis, less metabolic disorders, less foot problems, just in the end, those are the intangibles that help add to the plus column on your income versus the minus column on your expenses. And I think with that, this is what I'm looking forward to, making some hay. Thank you very much.
I think you got a couple days anyway before you need to get out there. Well, thank you.
This is the other issue.
Yeah. Yeah. Thank you. That was great, really informative. I know I learned a lot, and I'm assuming, your example with BMR corn is truly an example, just a representation of what a highly digestible feed can do. Because I know we do have a lot of grass only folks on here probably thinking about, okay, what does that mean? What does that mean for me? I don't necessarily have BMR corn. So anything you want to add? I think it's the principle that you're
exactly.
focused on.
That was the easiest way at the time at Miners, the only way we were going to vary NDFD from forage. But I do have, if we have time at the end, I have my ration program up that shows it doesn't take much. If you can improve that 30-hour NDFD value by just 5 units, you will see a difference. It will make a big difference. The closer you get to that 60% digested value, the better.
Excellent. That's a good goal for people to think about.
Yeah.
If there's any quick questions for Kurt right this moment, otherwise we're gonna get Sid going here. And Susan's putting up another
Stop the
pop-up
share.
poll for us about your biggest challenges. And that was one of the things I wanted to mention today. Sid, you want to get your slides up? If you're still there. I know in retirement, you probably have afternoon naps and
Yeah,
everything.
I just
so-
woke up.
Oh.
That is not
Hope it-
true.
Did I give you your nap?
Anyway,
Do I need to share or do you share me?
nope, you're gonna share. But we do have a question, Kurt. So while
Yes.
Sid's getting going here, how does spoilage reduce fiber digestibility? Do yeast and molds digest some of the digestible portion? Thanks, Alan.
No, they are antimicrobial. So they don't necessarily affect the quality of the fiber, but they affect the rumen fiber bugs, the yeasts and molds.
Great. So one of the, we have another new project outside of the other ones we've already announced during this webinar series, and one Kurt was mentioning. But our team, as well as the University of New Hampshire and USDA ARS in Wisconsin and Pennsylvania, and as well as in California, we are on the trajectory to develop a a perennial forage research and outreach agenda for the nation. And I mean, Kurt's on here and Sid's helped us a little bit with the survey that we're developing. So we are going to be putting out a nationwide survey to folks here in a little bit, not right away, but what we are gearing up to host in April is some focus groups. And these should not take too much of your time. It'll be about an hour and a half of your time. They'll be virtual. And if you're interested in serving on the focus group, it'll pay $100. And again, it's an hour and a half of your time, virtual. They're going to occur in April, probably about the third week. Farmers, consultants, seed dealers, anybody who wants to give us feedback on the research and outreach needs of forage, we want to hear from you. So send me an email. Kurt, I'm hoping you might be willing. Put you on the spot right here.
Sure.
But otherwise, yeah, just send me an email. We're looking for some willing and able and interested bodies to serve on the focus groups here in the East. So, all right, Sid, we do have one more question. Would rapid pasture Ndf digestibility be a concern for ruminal acidosis in grazing cows?
Yes, absolutely. And that's why it needs to be paired, that rapid forage, even though you think it's just forage and not acid producing, it does produce some acids, and the fact that it ferments so quickly, it needs to be slowed down, and we can manage that either with a dry hay or something, or other feedstuffs. If I could amend my previous answer, the yeasts and molds can affect the forage NDFD by their occupying sites of digestion where the rumen bugs might attach. Yeasts and molds can be in the way and affect the forage digestion that way as well.
Great, thank you. All right, Sid, we're going to turn it over to you.
All right, so can you hear me okay, Heather?
Yes, we can.
And is my presentation up and running?
Yeah, it looks good to me.
Okay.
I see a sidebar over here. I'm not sure, but I think overall the slides look good. So
Okay.
I would go with it.
Let's see if, okay. So Kurt, don't totally go away. Might be a question or two that comes up. But Heather, thanks for letting me be on the program. This is fun for me. I am retired now, but I have been able to do a few guest lectures this past fall, which was kind of fun to do. And it's always good. And I see a number of folks on the participating today that probably could give this talk better than I could. So I might pick on some of you. I think, let's see if I can. Okay. I'm starting with my last slide. Maybe I can just finish. But I do want to encourage, if anybody has questions for either Kurt or I, type them in, and we'll certainly try to leave some time to have any kind of discussion. So as a follow-up to Kurt's presentation, which was excellent way to introduce the whole area of forage quality, I'm going to talk about, more what's going on in the field. And not knowing who the audience would be, I've kind of put together certainly some of the things. Some of you may have seen this before, at least some of these slides. I do want to share some of the research I've been involved with, some with Heather, and some more recently, my most recent grad student, Alan Wilder, who's now at Minor Institute. And Alan, I see you're participating, so I just want to share some of his work when he was working on his master's degree at UVM. I can't, let's see, I've got to change something here, but I guess my first question is certainly, what's required? And I think Kurt already alluded to many of this. What do we need to do to achieve those quality goals? And I don't want to forget yield, because if we just focus on quality, we know economically we've also still have to maintain yields. And before I continue on, you're looking at this is an alfalfa grass field. I took this picture many years ago, and it was adjacent to a study I had up in East Montpelier. But my talk is on perennial forages today. Joe Lawrence, I see that you're participating today. Joe will be speaking about corn hybrids in a few weeks as part of this series. So I will let Joe address any of those corn silage issues. If any questions come up today between he and certainly the work Heather's done, or Rick Kersbergen's on the program, we can certainly have a discussion about it. But I'm going to focus on perennial forages. Certainly when I think about the list of production practices, factors that we deal with to grow our crops, but also to harvest and manage them, all of these can certainly play a role in quality. Susan just looked at the results of your survey from the participants, and it looks like cutting is still the most challenging, but certainly one that I think the number one you had there was cutting by a challenge of cutting due to weather. Okay, so I am going to spend some time on species and variety selection and relate some of the work we've done here regarding that. And the first question I always like to ask is, how do you choose the forages you use on your farm? Is it, based on seed costs? Certainly should be, but that shouldn't be a primary factor with a perennial forage. But again, my kind of laundry list of things to think about, yield is always consideration, but how do we have good information on yield? Maybe our own experience. I would encourage any farmers on the program, though, to utilize your local resources. There's a viable program, certainly here in Vermont, with a lot of the data that Heather collects on various varieties and species of forages. New York has a program. I'm sure Joe will be talking about the corn silage program, but he can also share with some of the other perennial forage evaluations that are done. When I think about seed and varieties, again, Kurt already alluded to the importance of species that might influence Ndf digestibility, but I think we also have to think about some of the protein dynamics, digestibility and energy. And then for our forages, if we're going to continue to maintain viable stands, which are the most tolerant to frequent harvests? Because again, if we need to cut immature forages to get the higher digestible forage, then we certainly need forages that can tolerate those type of intensive cuts. There's a few other things here we'll talk about as we go along the way. I do, again, don't want to forget yield, and I use this as an example. Orchard grass, we've grown for years. It's a very flexible grass, grows over a wide range of conditions, and tolerates frequent cutting, can be fairly persistent. But finding the most adapted species, I think, is really important for your soil. And I use this is an old graph that Jerry Cherney put together for a fact sheet of his, but I just like it because it really visualizes my point here that Jerry summarized orchard grass yields across the spectrum of drainage types, from excessively drained to very poorly drained soils. And you can see from this graph of potential yield for orchard grass that it will grow across a pretty wide range, but the yield potential can really decline rapidly when you start getting into those wetter soils. So again, picking species not only for being adapted for surviving, but for yield is really critical. And that's it. I just wanted to make that point, that even though we may maintain the grass in there, and we may have fields that we've been harvesting for years, what's its yield expectation? What are we getting out of those yields? But I really like mixtures, and I know most of our farmers grow mixtures. So I'm going to focus a little bit on mixtures, particularly grasses and legumes. Agronomically, we know we grow mixtures because we generally get a higher potential yield considering our wide range of soil conditions. It usually reduces our risks of stand failure, right? Due to either winter kill or pests. But it can be challenging in getting that desired mixture. Even if we go by specified seeding rates, we're not guaranteed we're going to get the mixture we wanted. And I think any of us that have done research with mixtures, we know the frustrations of trying to target certain mixtures across locations or even within the same study, and getting wide ranges of the proportions of grass to legume, even across a very small research site. Nutritionally, I think there's some real benefits to mixtures. Again, I'm speaking primarily here grass legume mixtures. Certainly a legume is usually going to give you a higher protein content or a mixture will give you more protein than grass alone because of the contribution from the legume. But the grass itself, even though it gives you total fiber, a higher total fiber, which might increase the fiber content in the mixture, as Kurt showed in his slides, those grasses usually have a higher digestibility. They can improve the overall digestible fiber in that mix. Just to illustrate this, this is from Alan Wilder's master's thesis work that he completed in 2019 and defended last year in 2020. And Alan just took all the data from, I think this is from the 2018 year. And I'll explain this study a little more in a minute, but it was comparing 3 legumes in combination with 4 different grasses. So across 2 cutting systems. And so it was a lot of data, and he just put all this into a scatter graph looking at the proportion of grass. So this is running from 0 up to almost 85% grass in all these different plots. And pretty good relationship by just looking at this component of to Ndf digestible dry matter, well, organic matter of the 30 hour. Okay. I think the biggest challenge for mixtures, though, is consistency or poor consistency, either between fields or over season or across years. It's really a challenge to maintain the proportions that's then going to affect the quality of the forage. I will say, though, even for monoculture forages, there's always a challenge of consistency across fields, across cuttings, and across yields. So it's not just mixtures, but I think that is an added challenge. While Kurt was speaking, I grabbed this slide because I really liked it and threw it into my presentation. So yes, I was paying attention, Heather, when Kurt was speaking. But I really like this summary from Cumberland Valley. But one thing I guess I'd like to throw out as an idea here, when you look at this dashed line is the cool season grass. Well, I'm assuming cool season. Most of our grasses are cool season. And this solid is the legume. But the other thing to notice is the bell curve itself. There's a lot more variation in the grasses than the legume. I mean, the legume has a pretty typical bell curve. Look at corn silage, a little even narrower, which makes sense. The grasses, though, have a much wider range. And I think every one of you probably are nodding your head, or if you're, I hope you are, if you're listening. We do recognize that's the challenge with the grasses is they think about the first cutting, they can head out quickly, they can respond to warmer early springs, they might head out more quickly, catch you off guard, be past their prime before you're ready to harvest. I think they're just more prone to many factors that can affect fiber digestibility. So I just threw that out as we were talking about it earlier, to think about, again, these challenges of either growing grasses, managing grasses for quality, or managing mixtures for quality. One question that oftentimes comes up, and this may be more pertaining to pasture, but sometimes certainly in stored forages as well, harvested forages, is the type of mix. What do you put together for a mixture? Should it be simple, a simple 2 or binary mixture, maybe 2 or 3 species, or should it be complex? And there's an argument that more complex mixtures can increase many of the ecological benefits that might improve yield or seasonal distribution. And there may be some truth to that in pasture management. I think it just adds to the complexity of trying to manage it. And I tend to lean toward more simple mixtures. Even of the complex mixtures, a lot of research will support that it's those 2 or 3 species within that mix that might have the biggest benefit for the advantages of that complex mix. But anyway, just something to think about in formulating mixtures. And then certainly the question is, which legumes do we consider for these mixtures, and which grass? So I do want to talk a little bit about legumes. again, yield is always a driving force if it's going to be economical. We can put up really high quality forage, but if it costs us twice as much per ton to put it up, then we have to think about, is it worth it? And again, within quality variables, when I think about legumes, digestibility always comes up, of course, but a lot of interest more recently in non-structural carbohydrates, and then degradable protein is always a factor when we think about legumes, particularly when we put it up for silage or haylage. And I'm just going to throw this out 2 or 3 times in my talk. Variety really counts when it comes to not only yield, but certainly to quality. I've seen a lot of data over the years, both in Heather's work and some of my work, and Jerry Cherney has done a lot of work looking at various grasses and looking at a lot of varieties. And clearly there's strong differences in their potential for quality. So can't stress enough, the more information we have on variety, the better. Okay, I just want to share a little bit from Alan Wilder's project. Alan, again, was a master's student with me, and we were looking at a project in collaboration with UNH, and this was funded by an organic NIFA project, USDA project. So the thrust of it was organic forage management, but it was really basically legume grass management. That certainly should be applicable to any situation. And this was a study that was located at UVM at their horticultural research farm. And it was a pretty big study, lasted a couple of years, and Alan was really put in charge of it. This was his master's work, but we were looking at 3 legumes: alfalfa, red clover, and bird's foot trefoil. And we looked at binary mixtures or 2-way mixtures of those in combination with 1 of 4 grasses or grown just alone. So we had tall fescue, meadow fescue, perennial ryegrass, and timothy. We could have had more grasses, but there was a constraint on area and on just the number of samples and plots that we could handle. So we were mainly focusing on these. The added element was we had 2 different cutting schemes. So all these combinations, these 15 different combinations, were either cut, we called it a delayed cut, but it was a 3-cut system, somewhat with the first cut delayed and a little longer interval between cuts, versus a more 4-cut system, something I would typically see in the Champlain Valley. In fact, when we were cutting our plots, was usually the same weeks that many of the dairy farms in the Champlain Valley were making their cuts. There were 30 total treatments, 4 replications. So it was a lot of, it was a big study. Alan handled it wonderfully. And I am going to throw out, because I'm going to bring it up, but because it was such an extensive study, we only had 1 variety for each of these treatments. And that is a constraint when you do this kind of research, because again, I just earlier said variety counts. We did try to select varieties that we thought were conducive for quality, either based on our own experiences or talking to various seed companies that had done their testing, or pulling from other projects. So I just throw that on for reference, and I will come back to it. So just a little bit of the data when looking at the legumes. And I have to explain this, these 2 graphs. The first one is 30-hour Ndf D, digestible Ndf. And the second graph is relative forage quality, which includes that number as well as other variables like protein and Ndf. And this is just looking at the total average for all the alfalfa plots compared to the trefoil or the red clover across all the cuttings in 2018. So it's accounting for all those mixtures of grasses as well as the different cutting systems. So this is kind of like if you were growing alfalfa with a grass mix, how does it compare to these other legumes across a range of grasses and cutting schemes? That's the way I look at this graph. And what we found was, and it may not be surprising, trefoil performed much better when it came to digestibility. It is, I think, a very viable option for highly digestible forage compared to alfalfa. We also found, I don't show it here, similar results in 2019. Just a little bit lower significance between these. The one that I was surprised at was the red clover, and it was much lower in this trial. The variety was Freedom, and I know Heather has Freedom in one of her trials, and I'll show some of that data in a minute. But what we noticed in our trial, this study was on a fairly well-drained soil, an Adams sandy loam soil. And most of the times when we were ready to harvest, whether it was the intensive management or the less intensive 3-cut system, a lot of times that clover was already in bloom compared to the other legumes. And I think part of it may have been the stress, I don't know, the stress in that particular site. It may have been this variety that even though it's very, it's been known for its quality and it's performed very well in Pennsylvania and other states, and even in Heather's trial, that's what we saw. So keep that in mind. When you, I don't show the yield here, but when you calculate the quality data in combination with the yield of these 3 legumes, we came up with, the calculated milk in pounds per acre. Even though the trefoil was higher in quality, its yield was quite a bit lower. So the alfalfa really came out far better overall in producing a forage that was at least going to predict a higher yield. Again, these are from a research trial, and you have to take that into account. But certainly trefoil, I think, has potential. Whether it fits on, a particular farm or not depends on soil type. But it's one that I think we need to keep looking at. And I kind of dispute, or not dispute, but I think there's enough other studies to show red clover has a much higher potential for quality than at least we found in this study. The other aspect of this trial, we harvested for yield, we collected for quality, but out of several, 10 total harvests that we made in those 2 years. We made silage out of 6 of those harvests. And we would basically collect all the forage from a plot, dump it on a table, mix it well, and then pull out subsamples for analysis. And one of those subsamples was wilted. We wilted to about 45% dry matter, I think is what Alan was targeting with, and then did a shrink wrap to make our silage. And I just wanted to show one bit of data from this trial. It really reinforced what the literature had shown, that this is soluble protein. So even though our focus has been on fiber, I'm going to mention this one graph on protein. But this is from one of the cuttings, but we really had the same trend of results out of 6 out of all 6 harvests. We know alfalfa can be highly soluble, highly degradable. Trefoil was less, and then clover was even less. Again, in thinking about managing for quality, I think this is a factor that might be important. We can talk about later. I'm going to move through. Just wanted to bring up, again, some work that Heather has been doing, looking at perennial forages. And this is a summary from the first full harvest year of a trial they're doing, comparing different, they have multiple varieties of alfalfa, trefoil, red clover, and white clover. And again, this is a summary from the first cut from their 2018 year. I just throwing a few slides out to show that, again, the trefoil had a higher Ndf digestibility. This was 48-hour compared to the alfalfa. Their red clover, again, was better than mine, than our study, but still a little bit lower than the alfalfa. This is overall. In the second harvest, again, trefoil was better than the alfalfa, but red clover and alfalfa were very similar. And I think, I don't show the data here, but in the third harvest, again, a similar trend. So Heather, I'm relying on you to figure out how we can get more trefoil into our forage stands. Since I'm retired, I don't have to worry about it anymore. But I do think it has potential. The other interesting one is white clover. You know, it doesn't yield much or well, but you're mainly harvesting leaf. You know, that white clover just has a petiole with a leaf on top. So when you harvest, you're mainly harvesting leaf. So it's really rocket fuel when it comes to digestible forage, digestible fiber. And again, higher than all the others, and has been consistent in her trials. I don't show the data here, but I did a study once trying to grow white clover, certain varieties with alfalfa. And I did one of those, in one of those cuttings, I pulled out the data, and I did find a nice correlation as white clover increased in percentage in that mixture, as you might guess. I was able to increase the overall Ndf digestibility of that mixture. And it didn't take much. It was, you know, if I had about 25% white clover in that mix, I could increase Ndfd by about 4 percentage units. So, and without hurting yield, actually. If I got over that, yield would be depressed. But kind of interesting to think about. Okay, so in her trial, in our trial, alfalfa certainly yielded the best. But this was from Heather's work, where they looked across their plots and ranked from poorly drained to excessively drained within that trial. And one thing that I think you'll see is this is a summary of the yields. I think this was the second cut yields in 2019. So going from poorly drained to excessively, certainly the alfalfa did the best in the excessively drained, and the white clover kind of tanked, which makes sense. But what I want to emphasize here is, as you go toward poorly drained or even well drained, some of these legumes yielded, you know, quite well. So I think whether we use red clover or even trefoil is going to depend a lot on our soil resources on our farm, or at least on a given farm. Are there certain places where we can utilize these crops, especially if we're segregating feeds, to shoot for a high quality versus a medium quality forage? Okay, grasses, there's a lot to choose from. I've always promoted the idea you want grasses that can tolerate intensive cutting, so you can cut them earlier. And there's a lot that we can choose from. I don't have time to go through all these. I'm just gonna pick and choose a few things. I don't have Timothy in this picture, so I will admit I've been biased against Timothy for years, but mainly because it didn't tolerate intensive cutting, but it does tolerate wet sites. It's very winter hardy, fairly easy to establish. And even though it's less tolerant of frequent cutting, there are newer varieties that appear to be much better at that. So I'm a little more encouraged. It's not a grass we should just toss out the window. And in fact, from Alan's study, when he summarized the yields of those 4 grasses, Timothy, tall fescue, meadow fescue, and perennial ryegrass, Timothy gave the best yields. Again, this is mixed with the legumes compared to the other grasses. Now, these were not necessarily significantly different. The only one that was really different was the ryegrass, which was not totally surprising. It's not going to yield as well as the other grasses. When it came to, and I apologize, there's a lot, let's just focus on a couple of things here. Of the grasses in Alan's trial, the ryegrass certainly was the highest quality, both in terms of protein, non-structural carbohydrates, and I think also Ndf digestibility. It's not on this graph, but unfortunately, it just doesn't yield as well. And therefore, when you calculate potential milk per acre, it was significantly less. And I'm not sure why it was less than no grass, but we did notice on occasion that we would get a yield depression when the ryegrass was growing in mixture with the legume. So again, from one study, so I don't have any conclusions on this, but it's something that might need investigating. All right, Heather, it's 12 till, so I don't want to, I'm going to quickly go through these because these are old slides many of you have seen. So I'll try to wrap up real quick so we can have any kind of talk.
Okay.
Let's go to stop now.
No, it's up to you.
Okay, just a little bit on meadow fescue. I've been excited about this grass for a number of years, but that was based on early on data from Wisconsin. The big thing I'd say right now is variety counts. I think there is some variation in the quality potential of this grass, and it's something that we need to continue to look at. Jerry Cherney has done a lot of work with both tall fescue and meadow fescue over the years, and so this is a summary slide he put together a few years ago, a couple of years ago, just to show, and again, this is from several trials. This is the effect of the grass as you increase the grass percentage in a mixture with alfalfa. His work is all with alfalfa. What does that do to digestible Ndf digestibility? And the dark line is combination of all the other grasses in the trials, tall fescue, I think, orchard grass. And yes, it increases digestibility, but this is the line for the meadow fescue. So it clearly overall has that potential to increase digestibility, fiber digestibility. Okay, and Heather and I did a 3-year trial. This is just summarizing the last year of that study, but we were comparing 5 varieties each of tall fescue, which is the red line, orchard grass, which is the blue line, or meadow fescue, which is the green line. And so these graphs get a little messy. This is the first cutting from the last year of the trial. And we sampled the plots twice, and then we harvested the last time. And just to see what the changes in quality was. So the dashed is Ndf digestibility on a 48-hour, and the solid line is just Ndf on a dry matter basis. And what you can see is, even though the decline in quality was pretty similar with the meadow fescue, it's it occurred about a week later. So in many ways, you could say that meadow fescue potentially could be higher because it gives you a little higher window of time to harvest and still capture a higher quality crop. But it still can be poor quality if you get caught either by weather or machine breakdown or something and not harvest till later. Okay. One thing from this trial we picked up. Now, again, these are the averages of 5 varieties each. So it wasn't just one variety, but this was the average date in which these grasses reached boot stage. And the tall fescue and the meadow fescue were about the same. They were the same date. Orchard grass was averaged a little bit earlier. And so even though they were about the same, that quality on a relatively date basis was better for the meadow fescue. Okay, I think part of the reason is that these two, I have two pictures. This is side-by-side plots of tall fescue and meadow fescue. And I took this picture on the 21st of May. And you can just see those tall fescue grasses are much bigger. Their yield was certainly higher, but they're going to have more midrib. So even by then, even though morphologically they may be similar, these are going to have more fiber in them, especially in those midribs of the leaves. And even though they headed on the same date, or they were in boot stage on the same date, I think the other difference is the number of reproductive tillers were more sparse with the meadow fescue versus the tall fescue. So on a relative basis, at that given time, you've got more stemmy reproductive tillers that you might be harvested versus the meadow fescue. Okay, now I took these pictures later. We had harvested before this, just so you know. I don't wait till it's this stage to harvest. But anyway, it just demonstrates that difference in the structure and morphology of these grasses. As far as our aftermath growth, second harvest and third harvest, the quality difference held in that second harvest. Meadow fescue actually did not decline as rapidly as the other grasses. So that was kind of interesting. And then even in the third harvest, the NDF level was lower with the meadow fescue compared to the other grasses, even though its digestibility was pretty similar than the other grasses during that late August harvest. So I just wanted to share that. Orchard grass, I'm going to skip through this. You can look at the handout. It's mainly just emphasizing late maturing can really make a difference again in the potential for quality. And I'm going to skip this because I want enough time for questions and answers. The last thing I will say, this is nothing new, but it I think supports what Kurt was saying is, cutting management is so important. And then I like to always say, if you're going to focus some of your harvests for the high quality, the high digestible NDF material, if you can get it in one or both of those first two harvests, I think you're better off. Perhaps the later harvests can go be segregated somewhere else. Or if we have a bad spring and we're delayed in our cuts, then we may have to shift our strategies. But I always argue these are the most important. They have the highest potential for quality. One, during this time of year, that's when we have the coolest temperatures, increasing day length. So those are going to enhance sugar content, higher digestibility. Later in the season, when you have higher temperatures, decreasing day length, that tends to reduce sugar content, enhances lignification. So it's going to reduce digestibility. And then the last one was a summary from that Alan put together from his thesis work comparing all those legumes. This was where we had two different cutting systems. So basically, by delaying that first cutting just by 10 days, which is significant, basically from in the Champlain Valley where we were, that first harvest was in late May to early June for the delayed cut. Delaying 10 days and then adding a 5-day interval, going from 34 to an average 39. So a 4-cut versus a 3-cut system. We reduced seasonal yield by 7%. Crude protein was reduced by 5.5. 30-hour NDF was reduced overall 7.4%. Non-structural carbohydrate 16.4. Relative forage quality 22.5. Milk per acre was reduced 14.9%. So if we took current value of 1760 per hundredweight milk, which is what I just pulled off the internet this morning, that comes out about a $519 loss per acre based on this one study. Okay. On the positive side, maybe taking 3 harvests instead of 4 might. Well, one, we have 1 less harvest cost, and it might increase persistence. We were not able to really determine that in this study because it only lasted 2 years anyway. With that, I'm gonna quit right there, Heather.
Great, thanks.
And
No,
I
that's good.
apologize.
No, it's good. We still have time for questions. And that was great. I think it's a really good time to be certainly thinking about forages, species, especially those folks that are getting geared up to put in some new seedings this spring. Yeah, if there's any questions, please type them into the chat box for Sid or Kurt. What is that big wet spot on the slide? Was that I didn't even see that one. That must have been one you didn't show.
Oh, yeah, I was going to get into weather issues.
Yeah, I know, thinking about these, and maybe Kurt was you or mentioned it, or maybe Sid, or maybe it was on a different call I was on today, but just talking about the weather, and just thinking about, we seem like it's really wet, then it's really dry, then it's really wet. Do we, are we ready? We're already sort of in this midst of something very different climate wise. Do we know what species are gonna, perform best in this really erratic climate? Are we ready? I mean, it's already happening. What do we do? What's your suggestion? Get my CCA credits. Okay.
So are you welcoming others to come on to speak as well, Heather?
If they want, yeah, nothing, if people want to unmute themselves, this is, yeah, something I've been thinking about a lot lately, are we kind of prepared? We're in the midst of this, so much uncertainty, and have we really figured out, with all the forages we have in the Northeast, what are the best species or varieties, combinations that can withstand this craziness?
Just a couple of thoughts. I did have a slide I didn't show of tile drainage too. Boy, more and more farmers are putting that into, again, try to mitigate some of those wet springs that we've gotten.
Yeah.
But I wonder about with forages. I think Kurt mentioned, summer annuals. And Heather, I know you've done a lot of work with that. So should we be spreading our risks by, again, maybe increasing our crop rotations with some of these various types of crops to spread that risk?
When I was at Jasper, we had one year that we were able to plant some millet, midsummer. It was hot and dry. We planted
Yeah.
it and got 2 huge cuts off of that.
Was that pearl millet or Japanese millet?
It's pearl.
And you were talking about corn silage before, and I know some of the farms on here are grass only organic, so they can't use corn silage. But we've got BMR varieties for the summer annual sorghum,
Right.
grass or Sudan grass. So
Yeah.
I think their fiber digestibility potential are quite good.
Yes. A couple of comments I made as you were speaking. Weather windows. I hear so often say, it's too short, I'm going to wait. And then you wait and it rains and you got to wait longer. It's like, boy, just when you've got the opportunity, take it and get that extra cut in.
Yeah.
I think that your last slide alluded to that, the value of that. Even if it's short, take what you got if they're giving you the chance. The other thing is if you do have a later harvest, the thing is mature and you know it's going to be stemmy, if you're chopping, chop it shorter. That matters. And chop it a little moister, not wet, but instead of 40% dry matter, just mow it and chop it as soon as you can, or round bale it, wrap it up with a little more moisture than being too dry. It'll help digestibility, help intake and digestibility.
So Kurt, you brought up about, being able to segregate your forages to target feeding that higher quality material, the higher digestible to the cows that really can utilize it. What's the best systems you've seen, or as far as out there that seem practical? I guess it depends on the farm.
Yeah, it depends on, nobody has an extra bunker silo sitting around empty usually,
Right.
But certainly ag bags or tubing can allow you to separate it. But please do your best not to pile it on top of a lower quality feed. That just defeats the purpose of raising it.
Great.
Yeah, sorry.
No, it's super. I know that we noticed this year, we still have a lot of fields that are that sort of traditional revert to, or just there, sort of that Kentucky bluegrass, white clover. And it seems to be really suffering under this new climate regime. And I see fields that seem to be even more unproductive because of these long stretches of drought, especially with that Kentucky bluegrass and white clover. And just wondering if the change in climate will essentially maybe start moving those species out anyway, or if you had any thoughts on that in particular, because that's a lot of what our hay fields and pastures look like.
I'll ask you, how does drilling in a summer annual do on a field like that?
Not very well.
No?
Yeah, I see somebody else wants to chime in, like, no, don't do that. But yes, Vernon, you want me to unmute
I
you?
can unmute myself.
Oh, there you go. Okay.
Yeah. Hi, Seth. It's been a long time.
Yeah.
My question is about, I see most of those research studies you did were done on organic fields, and actually I don't have any cows anymore, but I do grow forages and I put up haylage. So my problem is, of course, just manure alone it's hard to get enough nutrients. And I was wondering how you met the nutrient requirements in those fields for those grasses you were growing. Were you using ammonium nitrate and things like that? Not, you couldn't use ammonium, but sodium nitrate and stuff like that?
Yeah. Well, certainly in that mixture study, we had the legumes, so we didn't have to worry about nitrogen.
Yeah.
And I knew it was a short-term trial. And to be honest, that field hadn't been organic that much longer.
Okay. Yeah.
And so I felt like for a perennial forage crop, it really wasn't treated much different than, I made sure it had adequate potassium and phosphorus and it had been limed, before the trial started.
Okay.
But I agree with you. If this was just a grass trial and we had to worry about nitrogen, that becomes an issue.
Yeah, with this manure, you can't really meet the requirements that you would like.
It's more challenging.
Yeah.
But
yeah, I'm shaking my head too, because this is a big issue that we see, I feel like, on a lot of farms where there's just not enough legume out there, and the challenge of meeting the nitrogen needs becomes more difficult and also more costly. And so how do we keep those legumes out there, especially because we are adding manure and so on and so forth. But I feel like we could do a better job there and make some gains. Yields, quality, I don't know. I see a lot of only grass fields. And unless Kurt just said something that I missed, did you say we could only feed grasses? He's like, no, I didn't say that. But yeah. I feel like
I'm good with grasses, but
yeah, I feel like we could definitely use more legumes in our system. It's problematic. So there's something else here from Catherine. This may be obvious to everyone else, but can someone explain if there is a difference in forage quality between making the same forage as dry hay versus insiling it or making baleage? And
I'll let you take that, Kurt.
I was just
Yeah.
gonna thank Joe Lawrence for putting a few resources in the chat box as well. Thanks, Joe.
cool. Thank you, Joe. Generally, no. I mean, the starting point is the same, right? You're just preserving it differently. If you preserve it well, no matter what system, you should be able to maintain your nutrients. The question is, which are you best suited to do preservation wise?
Great.
If I just add to it, if everything's done, quote unquote, right, other than the protein issue around solubility, there probably could potentially not be any difference, right, Kurt? I think it's more a matter of when that forage is sitting out there for the number of, extra time you need to make hay, that's where the risk of losing quality might occur. So your
Right.
chances of higher quality or of achieving high quality with hay only, I think can be tough, certainly in our climate.
Great. Any other questions? And I don't know if we really answered your question, Vernon, but I think Sid, I feel like we have gotten really good and really high yields on our organic only fields that we have, but they really need to be mixtures, not single species, because of the nitrogen demands as were noted. And
Well,
I think
I've been able
that's
to get-
critical there.
I've been able to get reasonable yields, but and actually, as Sid probably knows, I haven't plowed any fields in so long. It's not even, long time. I mean, we're talking native grasses and white clover is all I'm working with. And but if I could, I know if when I was conventional, I could use urea or whatever, I could, my yields would be 20-30% higher than they are now, easily. That's all.
Yes. All right. Well, great. We are a little over time, and I want to thank Kurt and Sid for speaking today. Thank you so much. And we do have 2 more webinars left in our series. On Thursday, we are going to hear from local researchers, other local researchers, John Barlow, Kathy Soder, Miriam Snyder, and Andre Brito, talking about different dairy focused research projects occurring around the region. And then on Friday, Joe Lawrence is going to join us from Cornell and be talking about corn silage and hybrid testing and management tips. So hopefully folks can jump back on and listen to these other great webinars as well. So thanks, everyone. Thanks, Sid. Thanks, Kurt.
Thank you.
Have a great day.
You too.